And now I think that at this point we can dive right in. Welcome to today's session, which is organized by the European Journalism Center, the EJC, and the Copernicus Land Monitoring Service. It's a great pleasure to have you all here. And I would like to start by very quickly introducing the European Journalism Center, the EJC. I think you should be able to see my slides now. I am Zlatina, and I am part of the team of the European Journalism Center, or the EJC, which is a Dutch-based nonprofit organization that works since 1992 to support, strengthen, and develop journalism in Europe. You can find out more about what we do and how we do it on our website at ejc.net. Why do we do what we do? Because we're absolutely convinced that journalism plays a crucial, indispensable role in democratic societies and that it provides credible and reliable information, empowering people to make informed decisions and to hold power to account. Since the EGC was established, it has built a network of more than 50,000 journalists in Europe and not only. We have designed more than 200 of journalism resources, and we have organized more than 50 journalism-related events in the last 10 years. How do we support journalists and media organizations? Our activities are focused in three main areas. The first one is providing funding, training, and mentorship coaching support to media and journalists through our grants programs. And I myself, I represent the grants team at DGC. The second focus area is the organization of various in-person and online events. And the third one is knowledge and resources, where we organize various trainings like this one. We design guidelines, handbooks, etc. Some of our programs that I would like to just briefly mention, because those are the most recent ones, but also relevant to today's session and how we got here. The EGC is partner to the Investigative Journalism for Europe Fund, IJ4EU, which supports cross-border collaborative investigative journalism in Europe. We're also partners to the Journalism Science Alliance, JSA. Both programs are funded by the EU and will have their next open calls in January next year. So in case this might be something for you, please follow us, subscribe to our newsletters, and stay up to date at ejc.net. A smaller scale but equally important initiative that the EJC is implementing in partnership with Revolve Media is the Climate Frontline project, where we work with 4 local and regional newsrooms, 2 in Spain and 2 in Portugal, supporting them to build resilience and improve their capacity when it comes to reporting on climate hazards. And what these programs have in common, what we received as feedback from our grantees, from our communities, is that journalists still struggle when it comes to accessing high quality, visual, compelling data to support to tell their stories. So when the Copernicus Land Monitoring Service reached out to us and told us that they have this training in mind and that they basically can help journalists to use satellite-based technology and land monitoring to add evidence, to find stories, to track and visualize climate and environmental change, we immediately knew that this was spot on and an opportunity that we cannot miss. So it's with great pleasure that I would like to now give the floor to Sara Moraca, who is Communication and User Uptake Officer for the Copernicus Land Monitoring at the Joint Research Center. She will introduce the rest of her team and she will lead today's session. And before I give the floor to Sarah, the last thing that I would kindly like you to do is to do a little online check-in, and you can find the link in the chat. Just share your details so that we know who attended today's session, so that we can follow up with the resources, but most importantly to ask for your feedback, because we were just talking to our partners from Copernicus that we would very much like to maybe do something like this again, and it's important for us to hear from you and to try to improve. So thank you very much, and over to you, Sarah.
Hi, good morning to everyone. I'm a little bit nervous but excited to be here. So today's session is about understanding how satellite imagery can become a powerful ally for journalism. We often image Earth, planet, Earth observation as something technical and very far from everyday life and for the work of a newsroom. But in reality, this image allows us to tell clearer evidence-based stories about what is happening to our land, our forests, our city, and our environment. So I speak about this not only from my current role, but also from my own background as a journalist. I know some of you that you are joining on the other side, and I first encountered the European Journalist Center years ago, also Zlatina, as a grant recipient, and that experience deeply shaped the way I see the value of trustworthy data in investigative projects. So being here today feels especially meaningful. It's an opportunity to give back and to offer fellow journalists practical tools that I really trust can open the door and change the mindset that we have in respect of satellite data and all these tools that can be really accessible for us as a journalist. So at a time when misinformation on climate and environmental issue continues to grow, I think that having independent and verifiable sources is very important. So satellite data help us move beyond claims and actually see change unfold where it's deforestation, urban expansion, drought, in fact, or shift in land use. So our goal today is not to turn you in a remote sensing expert, but to show that these tools are open, accessible, and ready for use, even without a technical background. It's not necessary. Think of this webinar as a practical introduction to integrating satellite-based evidence into your reporting, enriching narrative, and have more powerful investigation. So with that, it's my pleasure to introduce you briefly my colleague. We have Simone Balbo, Project Officer at the JRC for Copernicus Land Monitoring, Andrea Lupi, Land Cover and Land Cover Change Expert, also at the JRC, Joanna Balazis-Levinson, responsible for user uptake at the European Environmental Agency, and Laura Priscal, in-house consultant and the European Environmental Agency. And after this general introduction, it's my pleasure to hand over to my colleague Joanna from EA, who will guide you through the Copernicus Land Monitoring Service over, let's say, an overlook of Copernicus and the service and the resource available to support your work. Thank you.
Thank you very much, Sarah. Let me see now if I can manage to share our slides. Here we are. It looks like you see them. Let me make sure that we can also see our slides here. So, and whether I can change the slide? I could. So, thank you for the introduction, and thank you for having us here today. It's really great. Now, first, a brief overview of the agenda. So first, we would like to introduce you briefly to the EU Space Program and Copernicus, which is the framework we're working in. Then, in order to introduce parts of our product portfolio, we will tell you the very exciting story of the life cycle of chocolate, something that everyone loves, naturally. Then a bit touching upon how you can access our data and create some visuals, hopefully for your work. Then we will do our best to answer whatever questions you may have. And if we don't have enough time, I'm sure we can follow up afterwards. And then finally, we would like to present briefly a media toolkit for you. So let's see here. Now, the EU Space Program and Copernicus. The EU Space Program was the first integrated program created by the European Union to support, for example, the space policy. And this has a number of flagship components that are called, such as two based on satellite data. One is Copernicus, which we will touch upon today, and the other is called Galileo, and is kind of the European GPS system. Copernicus, that is then the Earth observation component of this infamous space program, which is managed by the European Commission. And that has on its own three additional components. One is the space component, which consists of a number of satellites flying around above us. The data that these satellites acquire are used to develop a number of services. And these services then are validated using observations collected on the ground, so-called ground truth data provided through the in situ component. And a highlight of the Copernicus program is the access to fully free and open data, and the fact that all of these data and products, whatever they may be in terms of user manuals or technical reports, everything, this is provided in a harmonized way across Europe, and it's consistent in time and space. So when we have a satellite that gets old and it's about to stop working, then the follow-on satellite has already been launched to make sure that we have this long-term data acquisition. So if you think something sounds interesting, please don't get demotivated because you think something will die soon. And this is a beautiful visual of how this all works. So high above us, we have a number of Sentinel satellites flying around, and they monitor the world around us, really. The atmosphere, the oceans, the land. They help us understanding climate changes and emergencies such as wildfires and earthquakes, and then security measures such as along geographical borders. And then all of this is validated, as I said, using data collected on the ground available through the in situ component. These 6 boxes are representing 6 so-called Copernicus services. And today we will talk about the Copernicus Land Monitoring Service. But before we do this, let's start with a bit of history. So the cornerstone for the Copernicus program was built in the end of the previous century through the so-called Global Monitoring for Environmental Security program. That was a European initiative enabling the acquisition of satellite data on a global level, but fully free and open and continuous in time. And this came about because there were a number of really brilliant European research projects that were based on satellite data from a given satellite. But this satellite might have worked for only 5 years, and then it stopped working, and there was no follow-on. And so the results produced were maybe brilliant, but couldn't be used by other types of satellite data and kind of just stopped there. So what was the value? So people were lacking both the access to continuous satellite data and also to long-term funding. And so then this so-called GMES was established to do something about this. And in 2014, the EU came in and started funding this and supporting the development. And so this is where we got these 6 Copernicus services established, which you see represented by the symbols. And then these services are implemented by the institutions on the right and are implemented then through 8-year work programs. So our work is funded in 8-year programs. So we're currently in the second half of what is called Copernicus 2.0, and we're currently paving the way for Copernicus 3.0. And so what is key here is really this continuity in data access. And everything that we produce, it's fully free and open, and what we produce today, we will also produce in 10 years. It may have improved in some way, but we're not stopping. That is really a game changer for the entire world, really, because these satellites monitor on a global level. Now, what we are working with here from the EA and JRC side is then the Copernicus Land Monitoring Service. And as the name indicates, this provides geographical information. And this information regards the land cover and land use and how things are changing, the vegetation state, the water cycle, so everything water-related, water, snow, and ice, the energy variables such as on temperature and soil moisture. And this is done on a European and on a global level. So here in Copenhagen at the European Environment Agency, we are implementing the European products, and then our colleagues in the Joint Research Center implement the global products. Everything that I'm talking about today and that my colleagues will talk about today as well is available on our website. Please give it a look. And before I pass the floor back to Sarah, I would like to briefly provide an overview of what kind of data products we have. So they're divided into 6 groups. The first is land cover and land use mapping. And so what does this mean? This means that we're mapping, for instance, where we have roads, where we have different kinds of infrastructure, where we have different kinds of green areas, where do we have a forest, where do we have a field, what kind of crops are on this field, and how are they changing over time. So here we can use the products, for instance, to map the transition from, unfortunately, in some cases, from green to gray. And it may not be the right way that things are transitioning, but this is how it is. Luckily, in some cases, it goes the other way. Priority area monitoring is then where you can zoom in. So these pan-European and global products, they have kind of a low spatial resolution, it's called, so you can't see on a building level necessarily what is happening. This is possible through the priority area monitoring products. So there you can zoom in and see how is this city expanding, for instance, what's happening here. The satellite data provides images like what you see here over a city or over the entire Europe. So you can see where do we have a town, where do we have a forest. And then in the biogeophysical parameters, we can see how some of these things are changing again, like the vegetation and the water layers. Where do we have water for like continuously throughout the year? Where is it only semi-permanent, and how is it changing over time? Ground monitoring concerns how ground motion monitoring concerns how the land is moving both vertically, so it's subsiding or heaving, and horizontally. So, for example, we're quite keen on living in a house facing the sea. But if we now build a new residential area next to the sea, then the heavy weight of these buildings will cause the ground to sink. And as you may very well be aware, then most seas are rising. And so if the land is sinking and the sea is rising, then you may get water in your basement, which homeowners usually don't like very much. Mm-hmm. So we can use this tool to monitor how things are moving and then hopefully prevent this intrusion of water into the basement. And reference and validation data can, for instance, be our product called EU Hydro, which provides data on our river networks and how they are changing. So really everything concerning the environment and how it's changing over time. Now, Sarah, over to you, please.
Thank you, Joanna. So imagine looking at the Earth from above, not as a map, but as a living story. Since we are journalists, we want finding good story. We can see a vast green surface that stretch across the landscape, but satellites reveal a deeper truth that not all green is the same. So we have dense and mature forests absorb most of the light, appearing dark and layered in the Sentinel-2 image. And that darkness represents complexity, biodiversity, life stacked in layers. In contrast, agricultural fields, plantation and smallholder crops create lighter tones, sharper boundaries, and geometric patterns. Next slide, please. Here we have we can pose on the crop at the center of our story that it's the cocoa. So here an image of the cocoa pod, its seeds and its structure, and it's a reminder that behind every chocolate bar stands a tropical ecosystem and the land that sustains it. So cocoa is often grown under partial shade, blending into forest margin, but still altering the canopy and its spectral signature. Next slide, please. From space, tropical landscape become legible. Decades of satellite image reveal how patterns evolve. So we have continuous forests becoming fragmented as clearing intensifies. agricultural plots shifting, expanding, or replacing forest cover, land use changes driven by crops like cocoa, among others. And this transformation leave sign that are exposed soil, disrupt their canopy, and new seasonal rhythm. Next slide, please. So today we know that 60% of the world's cocoa comes from just two countries, Côte d'Ivoire and Ghana. This concentration makes monitoring even more crucial. With the Copernicus and Land Monitoring Service, we can track key elements like my colleague showed, so deforestation and its dynamics, expansion of agricultural areas, and long-term land cover change pattern. I'm now passing the floor to my colleague, Andrea Lupi.
Thank you a lot, Sarah. So here we start looking to a recently published product, the Land Cover and the Forest Monitoring Dataset, LCFM, which gives now, let's say, a completely new way to read the planet. Why? Because it takes the raw complexity of the Earth's surface and it turns into something that is much simple and accountable as a classification. With this classification, we can follow year after year with scientific clarity, let's say, the evolution of the landscapes. This product is built on Sentinel-2 data, and the LCFM dataset offers a global annual land cover map, which is enhancing actually the resolution from 100 meters to 10 meters from the previous dataset heritage. The reference year now is 2020, and is providing a consistent and harmonized view of the landscape. The great thing is that the CLMS data are provided as a service, so it will give a continuity in the time. So soon in the next months, the new year of reference of these maps will be published. So next slide. In the next slide, we can see the tree cover density layer, which is crucial in helping understand whether an area is a dense natural forest, a degraded stand, or a young regrow patch, or even, for example, an agroforestry system, where trees and crops actually can coexist. This is much often the case of the cocoa cultivation, for example, in the Côte d'Ivoire and Ghana landscapes that Sarah just mentioned. Next. We see here a Copernicus Sentinel-2 data image. Those data are the backbone data on which most of the CLMS product rely in order to be produced, but also, I would say, those data are a fundamental visual vehicle of a message about what's happening on the Earth's surface. This nice image showed the Monte Elgon region, which is the Kenya and the Uganda border, Eastern Africa, on which apparently everything is more or less green. But when looking, and let's see the next slide, when looking at what is classified by LCFM land cover map, we can see deeper, let's say, in the invisible spectral bands of the sensor, at least invisible for human eye, not for the sensor mounted on the satellite. And so discovering the actual extent of the cropland beside natural vegetation. You see here in pink the cropland, and in green and the trees, tree cover. So by comparing 1 year to the next, the LCFM dataset exposed crucial transitions concerning cropland, as for example the cocoa, but not only. And this data can track where a plantation expands or where degradation gradually thins the canopy. This long before a full deforestation is visible. And we can say this data can turn long-term changes into something that is scientifically measurable, traceable, and transparent, being, let's say, somehow a lens, which is a way to see the planet as a continuous story, where croplands, in this case, and natural vegetation are constitutes dynamic elements of a system which is evolving and changing through the time. Let's see in the next slide that among the CLMS data portfolio, there are also other data which specifically focus on priority areas. So giving here more detailed, some more detailed information about land cover and land cover change, and on crop types. This is the case. So the data you look into now is the hotspot monitoring and the Copernicus for geogram activities, which try here to map the distinction between crop types, which is not very easy remote sensing, because remember always looking from far in the space, and this is true particularly concerning the cocoa plants, which grows mostly in a mixed vegetation landscape. So next, just the word back to Sarah.
So thank you, Andrea. And through LCFM, we follow the story of the land, how landscape breathe, shift, and transform. But let's say that the planet story is also one of rhythms. So, forests living out and fading after drought, grassland cycling from green to yellow, and burn areas slowing healing. So while LCFM product reveals landscape structure, we have other Copernicus Land Monitoring products that capture their tempo, let's say, so seasonal growth, stress, recovery, and the imprinting of fire, showing when ecosystems thrive, when they struggle, and when they change too fast to adapt.
So I'm taking here back the slides. I'm replacing here our colleague Simone, which was initially responsible of the presentation. He cannot attend today, but I will give you the overview. So we have here we will see here other two products about the CLMS portfolio, the phenology product and the burnt area product, which add a dimension to the understanding of the land. This product reveals the seasonality product reveals the pulse and the stress, let's say the scars of the vegetation, the landscapes. The phenology product describes, in this case, with the season amplitude, the seasonal rhythm of the vegetation. That is the periodic plant life cycle across the growing season. So usually we can identify a period of the year with an inactivity period in Europe called winter, followed by the period of growth, which is the spring. And this period of growth reaches a peak and then a decline when it's autumn. So until it's finished. In this case, the CLMS product allows to detect and describes these dynamics. And the amplitude, the season amplitude here, with the colors growing until the dark, describes the variability of the vegetation activity. So in this case, the highest variability can be identified as usually being observed for the agricultural areas, while the lowest variability, so when the to the zeros or to the most red and orange can be observed for every green forest. Next slide. We see here another parameter offered by the seasonality is the productivity, total productivity. Here, the healthy vegetation consists with consistent green biomass shows the highest values of productivity, while at the minimum to null values, we can find areas with little or no vegetation present. Next. Here, a final quick look at the start of the season data. Here you see as the date range of season is narrow for areas which shows the same crop. For example, cocoa in our case. So when data here you see a uniform colored pink. In these areas, the vegetation are quite the start date is quite the same, where the variability of the colors instead is high. Consequently, it's represented for something that is not with the same vegetation period. The land surface phenology is let's say, an invaluable indicator in an ecosystem studies as in climate research, because these metrics reveal shifts linked to agricultural pressure or forest degradation. And let's say the next slide for next slide, we see the burnt area, the burnt product. Here, we can see as the area surfaces have been affected by fire, display significant changes in the vegetation cover, such as destruction of dry material, and where there's a reduction of green material or changes in the ground surfaces. These areas potentially are darker because of the ash. Yeah, thanks. So the products show how extensive these scars and when they happened. Here we are looking already to the burn fraction. Why? Because a fire can constitute a natural disaster in case of wildfires, but not always. Not always a scene of catastrophe, because in African region, for example, fire is could be part of land management. This in combination with agricultural activities. So yearly season burns are used to reduce the fuel loads, to protect villages and maintain grazing areas and prevent, for example, from more destructive late season wildfires. So from space, these management fires appear smaller, cooler, and more controlled, while the late season burns leave larger, darker signatures. So I finished with this overview. I give back the word, I think, to Laura.
Thank you very much, Andrea, for this overview. We have now been able to track the plantations and even see the impacts of slash burning that might be due to the deforestation of cacao plantations. And we have harvested the cacao, and now the cacao is transported to Europe. So once the cacao arrives in Europe, it is on us at the EEA to provide data and information about the consumption and the production of cacao. And because we have to consider that, as you can see here in the map, the EU is the largest importer of cacao with almost 60% of global import. And clearly, you can see that Switzerland, Germany, and Austria have some of the highest imports of cacao, which makes sense. And who doesn't love Swiss chocolate? So, as I mentioned, the cacao is transported to Europe, and it arrives in different ports around Europe. For example, in the Zeeland port in the Netherlands. And here with the CSC Plus backbone layer, we are able to find these ports and track the land change in those areas. So track how ports develop over time. So here on the map, you can see in red the sealed areas. And if we compare it to a year previous to that one, we could also see how this might have changed. So how maybe due to more and more import ports are growing, and therefore we have more and more sealing of soils. But a chocolate bar doesn't just consist of cocoa. Actually, my favorite chocolate bar consists of cocoa, almonds, and salt. And therefore, we also have to trace the almonds for our chocolate bar. And we were able to trace some of these almond plantations with our crop type layer. Our crop type layer mainly shows us different crop types that are harvested around the pan-European area. And with the help of a little bit of satellite data, but also with the crop types, we were able to find our almonds for a chocolate bar in the south of Spain. And almonds are usually a perennial crop, meaning that they don't change that much over time. So here in the map, you can see in green the almond plantations, but then you can also see that the different colors change over time because those might be annual. So we've been able to find our almonds, harvest our almonds, and now we have to get our last ingredient for our production. And our last ingredient is salt. Salt is usually harvested from salt flats, as you can see here in this image. And salt flats can be found around different areas in Europe. We went on the search to try and find our salt flat for our salt for a chocolate bar, and we found it in the south of Spain, in Cádiz. By combining satellite imagery and also the permanent water cover, we were able to find our last ingredient, salt. Because as you might know, salt flats are formed in regions where water from rivers and streams flows into basins. So with the help of the water and wetness, we can see which areas are wet and might be also areas where salt can be harvested, because salt evaporates over time. Well, the water evaporates over time, and then salt is created. So the cacao has reached Europe. We have been able to harvest salt, to harvest the almonds for a chocolate bar. And now all of these ingredients have to be mixed together and formed into my favorite chocolate bar. And in order to do that, we actually need to use water. And with the European Ground Motion Service, we actually are able to see how industrial processes might use groundwater, and this might lead to subsidence. So here, for example, we had a look at the Ferrero chocolate factory in Italy, because who doesn't love Ferrero chocolate? And all of these green dots are actually measurements, and you might think, what is this? So these actually show us how land is changing over time. As my colleague mentioned before, we can measure horizontal land change, but also vertical land change. And here we can see actually, which is very good news for us, that Ferrero is not overusing the groundwater supply, meaning that we can happily currently consume Ferrero chocolate because it's not leading to subsidence. So we have now traveled around the globe and looked at the life cycle assessment of cocoa through CLMS data. From the cocoa bean to my favorite chocolate bar with almonds and salt. It goes through a lot of complex stages, and this process has a very significant impact on our environment. For example, due to the deforestation of cacao producing countries such as Ghana, but also due to the emissions that are generated in the production and in the transport of cacao and the chocolate bars, but also due to the high water consumption. And all of these processes, as you might know, lead to greenhouse gas emissions, which in turn impact our climate. And so the impact that we have as consumers can also be tracked through the Copernicus Land Monitoring Services, because we provide data on environmental change. Here, for example, on the map on the right, you can see the permanent snow cover. It is for a glacier in the Alps in Italy, and you can see how the permanent snow cover is changing over time. So as you might know already, glaciers are melting. But we can also see other impacts, such as, for example, water surface temperatures increasing. We can also see shorter ice cover durations and also the declining of our water quality. So all of these changes that I just mentioned impact and mention the broader ecological footprint that we have with our consumption. It also emphasizes how we as consumers have to make sustainable choices and also informed consumer choices. So you might ask yourself, we have showed you this life cycle assessment of chocolate and cacao, but how can we actually get access to this data, which might be very important for you as journalists? So most of this data is actually available at the Copernicus Land Monitoring Service website. At the end of the presentation, we will give you a link. And here's the overview of our website. You can find the CLMS portfolio, which provides you all the data sets.
Sorry.
The dataset catalog, then a data viewer, which allows you to play around with the data without downloading it, but also use cases which showcase how CLMS data is currently already used in different areas and in different projects, and that might actually also serve you as inspiration on what can be done with CLMS data. So if we have a closer look at our CLMS portfolio, we can actually see, I will not go through each of our products. You can do that on your own time and explore around. But you can see that we have it separated into different thematic classes, such as, for example, priority area, biogeophysical variables, as my colleague Joanna mentioned before. And also very important, I think, for your work as journalists is actually the data viewer, which allows you to map the data without downloading it. So it allows you to play around with data, kind of see if there's a story or not behind our data that you might be interested in. And here, for example, I was able to map the imperviousness for mastfish, since mastfish is the area where the European Journalism Center is located. And in red, you can see the impervious areas, so the areas that are sealed, and in white, the areas that are not sealed. So this brings me back to Andrea, who will give you a closer view into different ways to access our data. Thank you very much.
Thank you a lot, Laura. So we're looking now to the CDSC ecosystems. This is the Copernicus Data Space Ecosystem, which is a different way to access actually the data compared to the CLMS portal and viewer. What is this is something different than a simple platform or than a portal, because it's giving access, yes, to the data itself, but it is also providing cloud data processing possibilities that constitutes a difference. And so by exploring the data section, let's see next. Next slide. Yes, exactly. There you can access this is the interface on the viewer, let's say, on which by which you can browse the data. So next, with the next slide, I indicate where to find the data collection and select next. Select, in our case, the CLMS data, which which we have published here on the CDSC. Next, you will see how to select the land cover map of SCFM. Clicking on the green button. Don't forget to do that in order to show the data with the last next with the last data available. So here you see the 2020 data set of the land cover map at 10 meters of resolution. And then you can next, please, Joanna, thank you. For example, by that button on the right, you can download your subset of your interested area of the product you are showing. In this case, it's the land cover map, but this is possible for everything is up here on the CDSC. So in the next slide, we can see, for example, the Sentinel-2 mosaic is a quarterly mosaic. Also, this can be visualized for the data you of your choice. Then we saw a subset drawn by the rectangle drawing, but you can actually draw also different shapes of your area of interest and download it always by the right panel button. This actually, in this case, I had the choice of the high resolution print download on which you can define your DPI of the image you will download. So that is very useful when you need to represent by a satellite image with a nice resolution. This is accessible and very, very easy to use. So back to Sarah, I think, for the question and answer time, I believe.
So thank you, Andrea. I think that's the time for the Q&A session. And as agreed, maybe I will pass the floor to Aiden, my colleague. I'm sorry, Aiden, I don't introduce you before in a proper way. Aiden Waller is my communication consultant from the EA. So Aiden, the floor is yours for the moderation. And also if Zlatina want to collaborate this moment.
Yeah, excuse me, I have a cold, so forgive my voice. But thanks everybody. I think there's going to be some questions for sure, judging by the chat. I think we should be able to answer them all, hopefully. Some I can answer myself, others I'll have to defer to some of my other colleagues here. But I'm just going to start with the order they came in the chat, and then people can actually feel free to raise their hand, I guess, if that's possible. And then if you want to ask the question out loud, feel free to do that as well. But yeah, we'll start. Let me scroll back up to the top here. We'll start with Kai, who kicked us off with a question about whether it's possible to measure the number of photovoltaic modules and track their development over time. I'm going to offer my answer, but then I would like an expert to confirm this. I think when it comes, I don't think that we have a specific product that tracks photovoltaics as a class. The first thing I think of when I think of photovoltaics in the CLMS context is a use case we wrote a while back where somebody used one of our other products, well, a combination of other products to find land that would be suitable for photovoltaic construction. But in terms of tracking actual individual photovoltaic farms or units on top of buildings, we don't currently have anything that is set to track that. And then Kai asked another question that I will throw back to Andrea about the productivity measurements, the phenology measurements. Kai wants to know how accurate they are. For example, start of season and productivity.
So in terms of resolution, we talk about 300 meters resolution. So every pixel is giving you the measurement about this area. And for the dates, please.
Go. Maybe the question, I don't know, but maybe the question was more about the validation. Is there
This
an
about,
accuracy
yeah,
number?
okay, for the accuracy of the data, let's say the quality of the data, I don't have it, now the number would be, but I can say that all the products are provided with quality accuracy and quality reports. So those information can be downloaded by the CLMS portal, browsing the data on which you are interested to. And yes, I'm sorry, but I don't remember by heart by the numbers of accuracy.
And if we're working on your question and you have a follow-up, please feel free to jump in and ask that follow-up or for clarification. But I'll move on to Robin's question, who is next, and she asks about tree cover density, whether it's good for estimating greenness in European cities or if there are better products. The answer is yes, and I think a lot of people have used tree cover density to estimate green space, but it works best in combination with other products as well. So we have a whole product suite called the Urban Atlas, which people use very often to track green space as well. That product has a bunch of different land classes. It's focused on European cities. But one of them is green cover because not all green cover is trees. So it works best to mix that one with other data sets. But yes, very much so, tree cover density can be used in that context. And then we have a series of questions from Ali, mostly related to the presentation itself. So the first one was about how do we know which ports the chocolate's coming into? How do we know that the sealed areas are cocoa? These questions are sort of on a theme, which is how did we know? Yeah, how did we trace the almonds? How did we know that they're going into this port? And the answer is that this chocolate story was not meant as an example of the sort of reporting that you will do. It was more so in other words, we don't know. It's just to illustrate that in telling a story, we can use these different products to sort of bolster our presentation of that data. So, I mean, when it comes to the almonds, for example, we knew a priori that this region grew almonds, and then through the data we can confirm that. But yes, in terms of like tracking an actual chocolate bar, that would require a much more in-depth investigation. And so the same sort of answer applies to the salt flats as well. And then the other question from Ali was, yes, the subsidence. Another great question. We can say that they're not likely they're not pumping from directly underneath the factory itself. It could be that they're importing pumped water from somewhere else. That's where the investigative journalism comes in. But if you were able to find that location, you would be able to clearly see it with the ground motion data. Ali, I feel like you had a lot of questions. Is there anything you wanted to clarify before I move on?
Hi, yeah, I'm just going to come
Yeah,
off mute. So, yeah, thanks
sure.
for that. So, I wasn't really sure in the presentation again if it was just like we have these products, they say that there is, here's a salt flat, we have this but because like you couldn't do a story, for instance, about a producer and make an allegation like they are leading to subsidence without having that clear evidence. So, my question is like, can satellite data actually confirm that, say, a sole industrial location is causing subsidence? Do you guys have enough confidence in that monitoring? And over how many years would you want to sort of see that to build that case, just to look at that specific part of the chain?
Yeah, I mean, I'm not an expert in environmental crimes, but we stand by the accuracy of our products, especially, ground motion in this case. I think my assumption would be that in any sort of, environmental crime context, you would need multiple lines of evidence to stack up. But for sure, I mean, for sure, EGMS has been used in the context of identifying illegal mines, for example, where, or at least identifying a starting point to further investigate illegal mines, because you can see that there's subsidence happening in a place where it really shouldn't be. So it's more to it's always going to be a combination of sort of on the ground. You learn things, you suspect a location might be, or you suspect somebody might be doing something, and then you can use the data to confirm it or not, or to support or not support your prediction, I guess, if that makes sense. Okay, and then I'll move on to Benedetta, who asks if you could talk more about the modality to identify salt marshes. So yeah, again, this is a very similar answer to Ali's, or very similar. I would give the same answer I gave to Ali, which is that maybe we should have made that more clear, that the presentation was not meant to show you a specific story, but rather inspire the types of data set that you can use to support your own stories. And this is a question from Robin that I do not know the answer to, that I'm thinking. Oh, sorry.
Get into
Yeah.
Just to get to Benedetta's question, back to that. So we can't say this out of this chocolate that the salt comes from this salt flat. But what we can do is identify where salt flats are located and how they change over time. We can do that with satellite data, but also with the water and wetness layer. So that we can do, but we cannot say exactly this bar has chocolate that comes from this salt flat. But we can at least have a look on how the land changes all the time in those areas.
But yeah, exactly. And you can imagine that if you did know that this
Thank you.
salt
That
came from
was actually my question.
Great. I'm glad to hear that.
Sorry. Thank you very much. Yes, I'm not interested in understand where come from the salt, but I was interested in understand how I can identify a salt marsh. So it is possible to understand and identify a salt marsh, because it's a pretty unique ecosystem. So there is water and there not. So it's not so simple to detect that type of wetland and that type of ecosystem. So at this point, sorry, my question is it possible to identify a salt marsh?
Well, it is hard to say if something is possible or not. I would say you can also contact me and we can have a more like a detailed discussion. What I can say is that with a combination of like satellite data, that's what I did to identify like the salt flats and the salt marshes. And then some data such as water and wetness and other layers, we can identify salt marshes. Does it clarify so well? If you have more details and you want to get to know more about the data, you can contact me, and I will gladly have a conversation with you about ways to do this.
Absolutely. Thank you very much. Thank you.
Thank you, Laura. And yeah, I don't, somehow the questions are like the order of them is moving in the chat as we go. So now Katerina has a question that wasn't there before, but I'm just going to read them in the order that I see them. Is there a possibility to search for specific shapes, so rectangles of a certain size, or buildings? Maybe I would ask, can you clarify your question a little bit? I'm not sure. I want to make sure I understand exactly what you're asking before we answer it.
Yes, thank you. So I would be interested to see whether there would be new developments. And like if you know where you're looking for, I guess it's easier. But sometimes you need to first find the location. So is there like a possibility to filter certain shapes that could remark like as a building?
Yeah, if what you're interested in seeing is like urban sprawl or like additional soil sealing, we have several products that are very good at that. One I mentioned earlier is the Urban Atlas, and another one Laura showed in her data access thing called the HR high resolution layer imperviousness. Both of them have a fairly long time series, and so you can see you can if you know the location ahead of time, you can switch between layers and watch more red appear in the area as additional things are sealed or new buildings are built. But if you're sort of fishing, you can also we have these change layers where every 3 years between status layers, there's also a change layer where anything that's statistically changed between those years is highlighted with everything else sort of washed away. So you can see these like sort of hot spots, I guess, where things have been built across Europe, by the way. So this is a 10-meter resolution across all of Europe. So you can sort of you can do both approaches, I guess, if that makes sense.
Cool, thanks. And to add on that, if I would be looking at actually certain size, for example, like 50 meters in length, is there a possibility to filter that?
So just to like filter by buildings that are a certain size?
Yeah.
That I don't know. Maybe Laura or Joanna
I can
or
add
Andre. Yeah.
something, Aiden. Once you download your data, then if you, I mean, you can play with your data. Once you use your layer on a GIS software, you can do this kind of filters once you are able to recognize it. No? For example, if you are using the LCFM data, you will find the built-up class. Then you can play with this and measuring the areas and the size and drawing your proper shapes as you wish. Then I would mention among the Copernicus other services, which is not the land services, that's the global human settlement layer, which belongs to the emergency management service, always from Copernicus. I put the link on the notes on the question and answer panel. And there you find also a lot of things I think you can be interested to.
Cool, thanks.
And just another note too, I meant to mention this earlier, but actually it's related to, I know there's Robin's question, I'll come back about the APIs, but it also looks like Simone may have provided you a link answer to that already. But Kai asks again if we want to get into a project using the data and there's some practical personal question we have about how to use it, how do we get an answer? One thing is that you can reach out to us, send a message to the help desk and it will get forwarded to the relevant person immediately. And we're very good about getting back. But then also the website, if you go to land.copernicus.eu, in the bottom right corner, you'll see a little icon, which if you click it, will bring you to our home built LLM, which was trained on Copernicus data and other stuff. So it's our little like personalized, Copernicus level ChatGPT module. Very secure, very safe. I know I know as writers we don't like ChatGPT, but yeah, it can be very helpful for answering very surface level questions about which data set might be good for this, which data set might be good for that. Yeah, that sort of thing. And then obviously if you have, there's probably certain questions it's not going to be able to answer. So then of course, feel free to send a message to the help desk and we'll answer it. And I think that's the list of chat questions, unless I missed anyone. But now we can, I guess, open the floor for any other questions. How are we doing on time? We have time. We have plenty of time.
Can we ask questions?
Yeah, please.
In voice as well. Sorry.
Please, yeah.
Perfect. Just to maybe follow up on the API question, I just wanted to ask if it's possible to, if I were about to use the Urban Atlas data, first part of the question would be, what's like this? Does it get released in like continuous steps, like every year, every 5 years or something? And I think the API question, I just need to read what was posted there, but
Sorry,
Is
the
it?
first part of your question was about like how the data is released.
Yeah, exactly. The Urban Atlas, like how often does it get released? How often is it published?
Yeah, so it's a different answer for different products, unfortunately. I wish there was a simple answer. Um, some of them are released on a every 3 year schedule, some of them are released every year. There are ones that are near real time. So it's kind of it's hard to give you a definitive answer, but I can Urban Atlas, for example, is every 6 years, I think. So the last version was 2018, but the 2021 release is coming very soon. So that's actually just another thing to note with CLMS data is that some of these status layers are quite old, I guess, relatively speaking. Um, some are as recent as 2023, others are as recent as 2021. So this CLMS is in for some data sets not a real time tracking thing. If you see something happening in the news and you want to be able to look at it in real time, depending on what it is, you're not always going to be able to do that. But there are near real-time data sets as well where you can do that to an extent, but there's only so many of them and they have very limited scope, I guess. And maybe I see
Yeah.
my colleagues unmuting to clarify.
Also, here, as Hayden already mentioned, we have different resolutions in time and space. You would say that the land cover and land change are more on a 3 yearly basis, while when we go into the biogeophysical data, that is more of near real-time data. So, for example, permanent snow cover, I think is almost on a daily.
Some products are daily.
Yeah, so some products have a daily measurement, which is actually very interesting and allows you for like it's a very high spatial resolution. Urban Atlas, as Hayden already mentioned, right now is a 6 yearly resolution, like time resolution, but also has quite the high spatial resolution.
And that is moving to a 3 year update frequency now.
Exactly. So we're trying to increase it. What we're also doing is we're trying to develop also new products that might help with different policies and support policies for Copernicus 3.0. So there will be new products released, and we also try to increase spatial and temporal resolution. And I hope that helps, Robin.
Thanks. It certainly does. It certainly does. Thanks.
Thank you very much. Ugo?
Hello. I know this. I understand this. This is not the objective or the main objective of this workshop. But I would like to know how can I use Copernicus, because we are involved in a project which focus wildfires. How can I use Copernicus to monitor the effects of the wildfires and other catastrophes in real time or in long term? I know that there is a functionality in the Copernicus for that. If you can talk a little bit about that, I will appreciate. I will appreciate that. Thank you.
Yeah, thanks for the question. I think there are multiple ways to go about it. We have a burnt areas product, which is dedicated to tracking burnt areas itself. But we also have various tree cover products where you can also often very clearly see the effects of a fire, sort of looking backwards, right? So if a fire was in 2021 and we have a 2018 and 2022 status layer, we should be able to see a huge group of trees missing in the latter versus the former. So there, depending on what sort of environment the fire is happening in, you can see the change in the land cover type itself. But again, yeah, there's also a burnt areas product. But in terms of real time, maybe Andrea, you could say more about like how you could use some of the seasonal, like some of the near real time vegetation stuff to track fires, or if that's possible.
The burnt area product, it is providing, I don't think it can be called real time because it's not now, but it really on very recent data. So I think Hugo, this is really the product that can be useful to your needs, because then you can summarize the areas, the bird, let's say, affected areas by wildfires, by monthly layers or yearly layers, or even day by day, let's say, evolution of the wildfires. And then remember, you can do your subset. So downloading just the area on which you are interested to. So drawing your shape by the rectangle, or drawing it online on the interface, or even uploading your, let's say, already draw the area by a shapefile or a JSON. With your JSON file. So I will maybe put a link in the question and answer chat directly to this product, in order to let you find it easily.
Thank you very much for that. I appreciate it.
Can I just add one thing? It also depends on what you are really interested in looking at, because we have some products that are updated on a daily basis, but if you want to really track the wildfires, for instance, in the real time or something closer, then you need to go to the emergency management service. Because we
Yes, my objective is short term, not of course real time. Real time, most of the time we are actually on the terrain. We want to monitor the wildfire in a short term, while it's many times the wildfires endure for a few days, and
yeah.
we want to more the burnt area. It's our satellite footage of the burnt area. It's what we are interested in, I guess.
Yeah, just to mention that we also have this emergency management service for something like this.
I'm sorry, I do have another question. I recently asked, I don't know which LLM I asked, but I asked one if there's any like overview, because sometimes I really try to use a lot of Copernicus data, but sometimes I struggle to know what the best location and what the best product. In the beginning, you talked about your 6 kind of services you have. And is there any like overview of which products are offered by which service and how I download them? I think the CDSE is probably the current main download portal. I think it used to be different in the past, but like, is there any overview of which product belongs to which service? And like, yeah, it sometimes gets a bit confusing to me.
I'm sure you're not the only one who it's confusing for. That's a very good question. To my knowledge, no. There's no clear overview of the different products that the services offer. Um, there's a third data access portal that we didn't talk about in order to keep things more simple, but that is called Wukeo. And I believe on that one you can also find the other services. I think, correct me if I'm wrong, but CDSC, I think we're the first service to migrate to. Is that right, Andrea?
Yes, but not everything is still there on the
Yeah.
CDC. That's
And
the
it,
reality, because it's on in evolution. Let's say things are onboarded. Let's say longer the time recently. So yeah, but I will put also the link to the wiki in the chat. Right.
yeah. So yeah, only the global data of ours is transferred to CDSC. The European data is coming this year, but there's this other one, Wukeo, that should have all of our data plus the service plus the other services. So besides going to their websites and sort of looking through their profile portfolios manually, I don't know that there's like a very clear overview. Unfortunately, there EU Space is planning to consolidate all of our disparate websites into a central website this next year. So hopefully something like that will be part of it, but unfortunately it requires some digging.
Great, thank you very much. Just so Vecchio is an alternative to CDSE, just hosts different data sets currently, or
Yeah, you can kind of think of it's what we were using before CDSE.
okay.
But as we transfer, we will
Got it.
stop using it, I
Thank
think.
you very much.
So that's why we didn't want to promote it, because it's not going to be here forever, and it's another thing to think about. So
Great, thanks.
A practical note is also that if you contact our help desk, and we can put the information in the chat, then the question goes to the team or to the specific product owner. So it may not seem very appealing to write a random CLMS help desk, but it really goes to the experts with the best knowledge, so the people who can best help you. So if you have any questions, please don't hesitate to contact them, and we will be here on the other side of the laptops trying to help you. Thank you.
And it looks like we have about 10 minutes left in our official timeline, but I can't remember if we had something planned for the last 5 minutes or something, but we probably have time for a few more questions if anybody has them. Kai, I'm just seeing your next question here. The closest resolution is 10 meters. So searching for meters of products of 1 to 2 meters is not possible. Yes, I think, but I will defer to my other colleagues on that one. In the raw satellite images, of course, you might be able to see them with your naked eye, but in terms of an actual like produced product, we don't have anything that tracks objects that small. That's correct.
Yeah, I just wanted to agree with what Hayden just said. Exactly, you can use satellite data and there you can track them, but we don't currently have TV as a land class where you could see exactly where these are. But you could always use the Sentinel data, which is also free of access, and download it. And you can download it.
So I think that we have a few minutes left, and I would like to just introduce the media kit, since we anticipate the fact that it will be one of the final stages of this event. So I'm just sharing my screen, but just shortly. Yeah, and showing you, here is our, if you go to our website, news and event, you are going to events, and we have satellite data for journalists, that it's the webinar of today. The bottom of the page, you will find the CLMS Media Kit. This is a very, let's say, short version of the Media Kit. We are keeping short in a first moment because we organize this information because we think you are pretty new about who we are, what we are doing, what kind of things you can do with our tool. So mainly it's really 5-page media kit, and it covers who we are just in one page to give you a short overview. And then we go very practically about, type of main topic you can cover with our data sets. Then we turn back on we try to run all the main information that we have covered in this webinar. So we explain shortly the map viewer with some example. Then we turn back off on the CDSE, as Andrea and I then explained, because it's a new platform and it will be more and more important in the European data satellite data context. And then we have an important section on our website, that is the use case. Actually, we have a very a growing number of use cases that are real example on how academics and industries or NGO are using our data for their purpose. So we describe which type of data set they are using, how they are using the methodology. And in this way, I think that, using some use case, reading some use case could be also useful for you to dig into the practical aspects of the story you could like to realize with our data sets. We have many European use case, but also global use case. So it's just going on the website and start reading, and we are pretty open to respond to any doubt on information on use case. And then we have feature article that it's they have really a wider clear background explanation, and we have a lot of interview there with experts from EA, JRC, but not just this institution, also other institutions, and a very good sources of visual material. This is a good example from Urban Atlas that my colleague in EA realized. So I think that both the feature article and the use case both could be really inspiring for you to really begin to play with our data and dig into some good inspiration for new stories. Just want to say that this media kit is the first version, and we are working on many fact sheets that will enrich this first version and giving you a wider overview on how you could use our data sets, and with more example, actually. So I'm turning back the floor to Zlatina at this point.
Thank you so much. Thank you so much, Sarah, Andrea, Joanna, Laura, Simone, who was also online, and Hayden, of course, who handled the questions. Thank you very much for your presentation, for your clarifications. Thank you very much, everyone who joined us. We really hope that you find today's session meaningful and that you learned something new, and probably that there are new tools or tricks that you will start using. You will hear from us after today's session. We will follow up by email. We will also provide you with the link to the BDA kit. And we would also very much like to hear back from you to learn whether this was useful, how we can possibly improve it, because this is something that we definitely think is valuable, and we would very much like to do this again and bring it to a next level. Thank you very much once again. Have a wonderful day. And stay tuned for any updates from us, and reach out to us with whatever questions or comments you may have. Thank you. Bye bye.